Today, we will be answering the question, how does the existence of employment laws affect the outcome of bargaining between workers and employers on contract terms, such as wages or hours worked? The employment law we have chosen to analyze is minimum wage. We are looking at its impact in the US due to greater data availability and differences in federal and state law, which allow for better comparison. We then settled on comparing California and Texas because the former has a higher basic minimum wage than the federal rate, while the latter has the same basic minimum wage as the federal rate.
Empirically, we will examine the impact of minimum wage on average hourly earnings, hours worked, and household income, comparing California and Texas from 2007 to 2024. California's minimum wage has consistently increased due to state policy supporting low-wage workers. Average hourly earnings rose more sharply, suggesting broader economic growth with a strong 0.8 correlation between the two variables. In Texas, where the minimum wage remained stagnant, no correlation was observed. However, average hourly earnings followed a similar trend to California, indicating wage growth is driven by broader factors. Despite the correlation in California, a minimum wage increase only led to a 0.03 percentage difference in wage growth rates between states, suggesting minimum wage may not directly impact wage growth. Moving on to minimum wage versus the hours worked. Despite rising minimum wages in California, hours worked showed no consistent trend with only a weak 0.4 correlation, making it difficult to conclude whether wage increases led to more hours worked. In Texas, hours worked fluctuated significantly, dipping in 2009, peaking in 2010, and then following a general downward trend. Overall, there is little evidence of a direct link between minimum wage and hours worked as seen in the 0.05 difference in growth rates between states. Since granular demographic data was unavailable for wages and hours, household income was also used as a proxy for wage rate and hours worked. We believe this proxy makes sense because our model, which we will discuss later, predicts that wage rate and hours worked move in tandem with each other. Looking at race, median household income rose over time in both states, suggesting minimum wage may not be a key factor. Growth rate differentials showed that three marginalized groups had negative differentials while white households saw higher income growth though not the highest. A similar trend for median household income can be seen for age. However, younger workers between the age of 15 and 24 had a negative growth rate differential, indicating they did not see proportional income gains despite potential wage increases. In terms of gender, median household income also increased. Female households had lower growth rate differentials than male households, suggesting wage increases did not translate into higher household income growth for women. Overall, these findings suggest that less marginalized groups such as men and white households did not have the smallest growth rate differentials, which was contrary to our original expectations. This may be due to capital gains and asset ownership, which disproportionately benefit less marginalized groups in California, contributing to greater overall income growth. Hence, growth rate differentials may appear higher, highlighting limitations in cross-state comparisons, as wealth accumulation and investment distort the impact of minimum wage policies.
To understand how minimum wages affect employment, we analyze the economic theory and model behind it. A key assumption is that each contract negotiation is independent. This helps explain differences between model predictions and real-world data, which we will explain later. Other assumptions will be introduced as we go through the model. We start by constructing the feasibility frontier. A concave production function due to diminishing marginal product is expressed in terms of first working hours and then transformed into free time. Assuming no saving or borrowing, production equals consumption, forming the feasibility frontier between consumption and free time. Next, we introduce indifference curves. Each curve represents combinations of consumption and free time that provide the same utility. We assume a Cobb-Douglas utility function, informed by research, giving convex indifference curves. Utility is cardinal. When workers own factors of production, they produce at the point where the marginal rate of substitution equals the marginal rate of transformation, leading to consumption C star and free time T star. Here, we need all the assumptions of utility, utility functions, and indifferent curves. Now, we introduce an employer. The employer owns all factors of production except labor, so the worker must be employed. Total production is split between them. The worker accepts a contract if they're better off than the next best alternative, IC prime. The gap between the production function and the indifference curve is the employer's share, while the curve itself represents the worker's share. The employer can offer any contract within the shaded feasible set. We then plot the employer's share of production on a new graph below. Since the employer aims to maximize profit, they select point A as the contract terms. Now that we have established the baseline model, we introduce a minimum wage and analyze its effects under two scenarios. The first is when the current wage is below the new minimum wage, and the second is when the current wage is at least the new minimum wage. Essentially, we're separating our analysis into two subgroups of the labor force, with one that is low-skilled and low-waged. First, we consider the case where the minimum wage is set above the current wage. Since their wages are below the minimum wage, we assume they are relatively low-skilled, and low-skilled workers have little bargaining power. So we model this as an ultimatum game, where the employer presents a contract and the employee either accepts or rejects the contract. The introduction of a minimum wage reduces the feasible set, limiting the employer's ability to negotiate lower wages. Therefore, we consider the size of the feasible set as part of the employer's bargaining power. We then plot the employer's new share of production, which is the red curve. As a result, contract terms shift from A to B, free time decreases from T star to T prime, while wages rise to the minimum wage from W star. Therefore, the introduction of minimum wage increases both wage rates and working hours. If the minimum wage increases further from W0 to W1, the feasible set shrinks again from the grey to pink area. The employer's new production share decreases, illustrated by the new red curve, and shifts the contract terms to point C. Free time falls from T prime to T double prime, and wages rise from W star to W double star, which is the new minimum wage W1. So, raising the minimum wage increases wages and hours worked. Now, we move on to scenario 2, where the current wage is above the new minimum wage. Since we assume that these workers are more skilled, both their production function and the next best alternative indifference curve are higher. In the first case, the entire feasible set is above the minimum wage, meaning contract terms remain unchanged. In the second case, the minimum wage may intersect with the feasible set, but actual wages, shown by the stars, remain above it. So, introducing the minimum wage has no effect. In summary, minimum wages don't impact those already earning above the threshold. Finally, we want to look at the case of Texas separately. California follows general trends where minimum wages change, so our scenarios apply. However, Texas follows the unchanged federal minimum wage, making it a variant of scenario 2, as shown in the two graphs. Here, the feasible set is either entirely above the federal minimum or intersects with it, but wages don't change. The minimum wage moved any lower wages up to the red point when it was introduced, which remains fixed afterwards. Thus, minimum wage laws have no effect in Texas.
Now that we have fleshed out our model, we shall incorporate insights from our data analysis to better understand the relationship between the data we analyze and our model. Our theoretical model predicts that an increase in minimum wage levels affects only the portion of the labor force earning at or below that threshold, scenario 1, leading to higher wages but more hours worked, while those earning above that threshold in scenario 2 do not have any change in their wages nor hours worked. However, in reality, employers would not set wages based on a single employee, but instead would have to consider labor costs across their entire workforce. This means that the overall impact of minimum wage laws on bargaining power should be smaller because there are those who are unaffected by minimum wage laws like those in scenario 2. This could explain why in our data analysis we saw that despite strong correlation between minimum wage and wage rates in California and Texas, the actual difference in wage growth rates between California and Texas was minimal. Similarly, while our model predicted increased hours worked for scenario 1, our data showed little to no correlation in both states, further supporting the idea that employers may adjust to higher labor costs in ways other than increasing hours. Our model also assumes that marginalized groups were more likely to be part of scenario 1 and would hence experience greater gains in wages and hours worked, causing the contract terms to move upwards along the indifference curve. However, our data analysis challenged these assumptions, where we found that increases in minimum wage did not consistently translate into higher household incomes for these groups. This could be due to employers offsetting minimum wage increases by adjusting contract terms, such as reducing hours or cutting non-wage benefits, which may have restricted the feasible set and limited their ability to move toward a higher indifference curve. Meanwhile, in scenario 2, we hypothesized that less marginalized groups such as white workers and men would start with a higher indifference curve above the new minimum wage level. Hence, their wages and hours worked would not be as affected. However, our data suggested otherwise, indicating that while less marginalized groups had higher initial indifference curves, their bargaining power may still remain constrained, as factors such as wage compression and limited upward mobility prevented them from fully benefiting from overall wage growth.
To conclude, our examination of employment laws and its effect on bargaining power outcomes broadly reflects the importance of combining both economic theory and data analysis. While data provides us with real-world insights, it is limited to observing correlation at most, making it difficult to isolate single variables due to third factors such as overall economic growth or changes in labor demand. Our use of household income, for example, meant that we could not distinguish whether income changes were driven by higher wages, more hours worked, or other components of income. Additionally, data gaps such as in the year 2020 meant we had to interpolate. These limitations then underscored the value of using theoretical models in explaining the underlying mechanisms and causal relationships. Although our theoretical models are an oversimplification due to the assumptions they rely on, such as treating employment as a take-it-or-leave-it game or capturing only a single player's decision despite complex labor market interactions, such limitations can be lessened when used alongside data analysis. Moreover, this model could also be used to provide insights into broader labor policies beyond minimum wage and working hours, such as parental leave and workplace safety and health regulations. Other economic models, such as game theory, could also be incorporated to address factors such as strategic interactions between multiple employers and employees.